You ready?
Yeah, I think so.
We're going to go once I click the slides. So. Okay.
Okay, Sophie, what's this paper all about?
This paper is all about jack-up vessels, and you can see a couple on screen. We use them in both offshore wind for installing wind turbines and maintaining them, as well as in oil and gas for drilling. At the bottom of each of the legs is a shallow foundation called a spud can, and these penetrate into the seabed.
Why is it so important to predict penetrations in sand accurately?
Well, the penetration into the seabed defines your contact area with the seabed, and hence your foundation capacities and stiffnesses.
So how do you predict spud can penetrations in sand?
We use a bearing capacity equation, which I hope is familiar to many, but this is taken from ISO2025. And we use bearing capacity factors using values determined by the guy on the right, Chris Martin. He's got various factors of his in ISO.
So what did you do?
We back-calculated jacking records, operative friction angles from quite a large amount of records we have in-house. And the aim was to work out the variation of the operative friction angle with respect to relative density.
Okay. Have you got some pictures?
Yeah, so these are, we looked at different size spud cans and relative densities, assuming we had CPT data on site. We eliminated layered sands and carbonate sands because that's too difficult for this study. It'll come later. And then we also looked at full contact and partial contact penetrations. So we covered everything.
Has anyone else looked at this before?
Yeah, this bloke. David White. He did it with centrifuge tests, so with little baby spud cans. And he also looked at the variation of operative friction angle with relative density.
So what did you find?
What did we find? This. The green shows large spud cans and the blue small spud cans. As you can see, there's quite a lot of scatter. But generally, you can see there's a weak positive correlation between the operative friction angle and relative density. And we've plotted the 80% confidence intervals just to show this. We also compared White's framework to our results. And whilst his seemed to match quite well with our upper bound trend lines, our data overall is more varied and across a wider range.
So what are the key takeaways from this study?
Well, we found that the operative friction angle is definitely not critical state. In fact, it was typically less than the critical state friction angle. It's also less than what White's framework proposed, perhaps due to the little baby spud cans he was modeling with. It's also much less sensitive to relative density than what practitioners will typically assume in assessments. And generally, for practitioners, we would recommend they remain within 24 to 35 degrees.
Cool. What will you do next?
Many of our records came from oil and gas jackups, so going forward, we'd like to include a lot more offshore wind jackup records to further refine our analyses.
Great. More details and discussion can be found in the paper.